Yeah, so this is week 5 for learning analytics tools, and we will be solving previous year's assignment in this session. So, previous year is the questions mostly are repeated. So, we will be redoing some of the questions which are currently in the assignment. But main motivation behind solving these questions will be to getting to understand what type of questions to expect in assignment also and in your final exam also, right? So you don't need to follow all these netiquettes which I have mentioned here, because we are generally less than 20 people in this meet. So you can raise your hands as and when you have doubt, or if you wish to add some important points to the discussion, or you want to you know no, just let us know some interesting facts. So then you can raise hand and unmute and speak. That also works very well. We will make this session as interactive as possible. So feel free to raise hands or type your doubts or your points in the chat box actively. I hope people who joined in late, the links to the PDF files are visible, and a link to the recordings of previous weeks. So I have shared the links to the PDF files which I used during the discussion, the marked PDFs. So that I have shared with everybody. I mean, those with the link can access different PDF files. I hope you all can see those URLs which I have shared in the chat box. I've pinned those messages. So anyone of you can check if the URLs are visible in the chat box of this meet. It's not visible for anyone, or is there any problem with my audio? Okay, great. Thanks, Ria. Yeah. Okay. So we'll move on to this week's content then. So this is the general format which we follow. Is we will do a quick recap of what content is done in this week. So it is a kind of good revision for everybody, and then we proceed to solve the questions. So this week's focus shifted from, so last week we saw descriptive analytics, where we saw different types of charts and when to use which type of chart, and so on. But this week we will be moving on to diagnostic analytics. Yeah, so diagnostic analytics deals with why a particular thing has happened. So with the help of log data, which are nothing but students actions, so we analyze these actions to understand why a particular thing has happened, or why things are not going as planned, or why things are going as planned, which actions are leading towards achieving of learning outcomes in a better way, or in not so better way. So all these type of questions we try to understand, or we try to answer using diagnostic analytics, right? So this is the main question which is answered, or which is the focus of diagnostic analytics, that why a particular thing has happened. So these are different techniques which we use in diagnostic analytics. So correlation is where we try to understand the relationship between, oh, it just got taken, relationship between different variables. So dependent or independent variable. So when we want to establish a hypothesis about relationship between different variables, like attendance of students and their performance in the mid-semester exam, or their performance in mid-semester exams, and their performance in the final exam. So at that time, the one will be a dependent variable, like their attendance will be dependent variable, independent variable will be attendance, and the variable which we want to understand how it is dependent on that independent variable is their score. So likewise, in different variables, we try to understand how they are related or correlated, how increasing one variable or decreasing one variable, how it impacts the other variable. Yeah. So this type of analytics is correlation. Then clustering is gives us idea about how variable 1 and variable 2 are affecting each other's value. No? So, and pattern mining is what are so pattern mining is so pattern mining uses the log data or actions, and it tries to understand what are the frequent set of actions or patterns. Then process mining, it will treat the entire log of our sessions, like for the duration which we are collecting that log data. So it will treat that process mining. So process mining will treat that as start and end, and it will try to capture the transitions between these actions. So this deals with transitions of actions in log. And it is also, what is happening? Gosh, is there log data actions? Somehow all what we are typing is getting undone. Transitions. Let's try undoing it from down. No, it's not helping. So log data. It helps us deriving a relationship between variables. Clustering also gives us a relationship between variable, how one variable is affecting other variable, how they are impacting each other. But clustering gives it visually, and correlation gives us some numerical values. Yeah. So there is a and plus correlation, we are not trying to group those data points, but in clustering we are trying to create groups which are groups of data points which are closely related, or which are kind of, so this is cluster 1, this could be cluster 2, here somewhere could be cluster 3. Yeah, so such groupings are involved in clustering. So even though we are kind of trying to create a broader groups among students, trying to create profiling of students, then at that time clustering we used widely or mainly. Then pattern mining will try to mine for frequent set of actions, sorry, yeah, frequent set of actions from log. And process mining will give us pictorial representation of entire log, and it also considers transitions among actions. Hmm? So these are the broad diagnostic analytics techniques which we will be covering in this course. But for this week the main focus of our discussion will be correlation and the state transition, not process mining, but just the transition part, transition of actions part. Okay, there'll be couple of questions from that topic. So we have seen which visualization will help us in determining correlation, that we have seen. So you all remember this scatter plot, and then we try to have a best fit line like this, and we try to understand how our data, how our data points are distributed in this graph in relationship or with in comparison with this straight line, best fit straight line. Okay, so this, the entire phenomenon is called correlation, that how this variables are related with each other. So there is a linear correlation, there is non-linear correlation, and so on. But here we will be dealing with measurement of linear coefficients. No, so sorry, yeah, linear correlation coefficients. So it will be denoted by rho or r. So we are dealing with two types of correlation coefficient: Pearson's correlation and Spearman's rank correlation. Yeah. So their advantages, disadvantages, and how to calculate them, they are already covered in their videos. So they measure only linear correlation, both of them, Pearson's correlation and Spearman's rank correlation, both of them, R and rho, they deal with the only linear correlation. And the values are in the range of -1 to +1. So the correlation coefficient will either fall between, so it will have some sign, positive or negative, and it will the absolute value will range from 0 to 1. So that means the total range of linear correlation coefficient falls between -1 to +1. So this plus and minus, that is positive and negative, have some indications of what type of correlation exists, right? So as you can see in this graph, uh, with increase in value of one variable, the value of other variable can either increase or decrease. So if with the increase in value of one variable, if the value of other variable is also increasing, that means there is a positive correlation, right? With x increasing, y also increases. That's positive correlation. And negative correlation is x increase, y decreases. So that's negative correlation. So this positive and negative sign denotes the type of correlation. Whether it will be how can say, the inverse correlation or positive correlation, likewise. So there's a question, what will be the diagram of negative correlation? Yes, it will be very similar to inverse relationship. So this particular diagram here is for positive correlation, and similarly negative correlation, where increase in value of x, this is our x and this is our y. So increase in value of x will result in decreasing value of y. So best fit line will be going, which will be going downwards and not upwards. So this line goes upwards here in this direction, and this line goes downwards. So this is negative correlation. Okay. So the main disadvantage of computing correlation coefficient using Pearson's and Spearman's is they consider only the linear relationship. That means when the best fit scenario is of straight line, but it does not consider the scenarios where there exists a correlation but it's not perfectly linear. No? So this is our x and y. So as you can see, there could be a best fit line going through it, something like this, but it's not a straight line. So there is a non-linear correlation here. Another example of non-linear correlation is y is equal to x square. So that graph goes something like this, and our points will fall along this x is equal to y. Yeah, so this will be the best fit line, but since it is not a straight line, this will be non-linear coefficient, a non-linear correlation. Yeah, so I hope things are clear. Positive and negative sign indicates the whether it is positive correlation or negative correlation, that is dealing with the direction of the straight line, positive or negative. Whether increasing one variable also increases another variable, then it's a positive relationship. When increasing one variable is resulting in decrement of another variable, then that's negative correlation. So moving on to formula. So we don't need to understand how this formula has come, but we just need to use this formula. Okay, so I will briefly discuss how to use this formula here. And we are not dealing with how this formula has come up. So I'll just write what every variable means, what every term in this particular formula means. So x bar is mean of x, one variable. So there are two variables. Variable 1 is x and variable 2 is y. So we want to find correlationship between these two variables, right? So x bar is mean x and y bar is mean y. And x and y are individual data points. The value of x will keep on changing for the data points we have with us. So if we have two columns with us, one is saying percentage in final exam or final result, and this is attendance. So let attendance be x and final score be y. So x1, x2, x3, x4 and x5. Let's suppose there are 5 values. Similarly, 5 values for final score. So now what we will do is, first step, we have this table with us and we are asked to calculate Pearson's coefficient, Pearson's correlation coefficient. Then what we will do is, first step is, we will calculate mean of x and y. So we will get x bar and y bar, right? X bar and y bar. Then what we will do is, we will calculate x minus x bar for all the values of x and y minus y bar for all the values of x. We can add new columns here and compute it. Once we have these values, we will find the, I'm writing it here, we'll find the product of these two, that is x minus x bar multiplied by y minus y bar. And fourth step, what we will do is, we will calculate x minus x bar square and y minus y bar square. Fifth step, find totals of x minus x bar square all, y minus y bar square. So all these individual terms we will try to find. and their summation. And now once we have all these values, we will put it in the formula, last step, and calculate our R. Okay, so my doorbell has been ringing for past 5 minutes. I'll just quickly go and open the door. Okay, I'm back. I have one doubt in the chat box saying assignment 5 question number 3 has no correct option. We will I think we'll discuss this next week. You come up, I'll go and check the question of current run, what is the question number 3, and then we will solve it, but not this week, next week, because we can't do that like direct question solving. If it is not part of previous year's assignment, we can't ethically solve it here again. Okay, so we will do this in probably next week's session. I will note it somewhere that we are supposed to get to the question number 3 of week 5. Okay.
Ma'am, excuse me, for me also getting the same thing, ma'am. But correct answer is not in the option. So what we will do, ma'am?
Okay, so if you're sure about it and the correct answer is not part of options, then I would say you can raise the query in the forum. Let the current TAs. So what happens is there is one dedicated team at IIT Bombay who handles this course, who have set the question paper, the assignments, and everything. So they have given these correct options to NPTEL folks. Likewise, they have, so there could be some mistake in marking the correct option from NPTEL end or from the TA's end. So these are all human errors. So we can simply point it out.
We understood, ma'am.
Yeah, right. So point it out in the forum that our answer is coming this which is not part of options. So kindly check if there is any mistake in marking the correct option.
Okay, ma'am. Thank you.
So if such things are there, what NPTEL folks do is they remove that particular question from grading, so that question, if that question is right or wrong, that doesn't matter in your final grades or your score. Yeah, so no worries there. If the correct answer, correct option is not there in the options, and you are sure that your answer is correct and it's not part of correct answer, then you can always point it out in the forum. Let the TAs know that there is some error there, and they will take care of it. Okay. So moving on. So here what this D is, let me change the color. Yeah. So this D is difference in ranks. So now what steps we will follow if we have to calculate Spearman's rank correlation? We have this data x1, y1, x2, y2. We will assign rank. Like in class, in our school, we used to get ranks assigned based on our score. Like the highest scorer used to get rank 1 and the lowest scorer would get lowest rank. So similarly, we will arrange these values into ascending and descending order, or anything is fine. You can do it in ascending order or you can do it in descending order, but you have to assign the rank independently to these two variables. And then once you have ranked, then either you can compute this Pearson's correlation for ranks, or you can use this formula based on difference in ranks of these two variables, right? Difference in ranks of two variables which we are considering for correlation. Yeah? So this is very easy to compute. You have to just assign the ranks, then get the difference, square the difference, add it, multiply by 6, divide by n into n square minus 1. Do anyone want to guess what would be n here? The normal stats notations. Yeah, yes, Riya?
Number of samples.
Yes, absolutely correct. Total number of samples. So in our example, there are 5 samples. So it will be 5 multiplied by 5 square, 25 minus 1, 24. So denominator will be 5 multiplied by 24, and based on whatever the value, we will assign the ranks and calculate the difference and then square it. So this is much lesser calculations, easy. We don't have to compute like mean first, then x minus x mean, y minus y mean, square it, then add it. We don't have to do all these things. This is easier to calculate, and it gives little bit, it considers little bit robust data set also. So if there are some outliers, then whenever there is a large value or a very low value compared to mean, then we are bound to impact these terms, right? X minus x bar, y minus y bar. If x is too large compared to x bar, then this difference will get impacted. So if there are outliers in our data set, then obviously Pearson's coefficient will get impacted. But since we are ranking them, so if a particular value is too large or just one greater than any number, so that rank remains the same. So this is a bit robust measure. Spearman's rank correlation is a bit robust measure, and you don't have to worry if you want to calculate Pearson's correlation coefficient or Spearman's rank correlation coefficient for larger data set, because there are formulae in Excel, or there are some online websites also where you feed your data and it calculates this correlation coefficient for you and gives the final value to you. Okay, so for this is just for understanding that how it is calculated. There will be some numericals in assignments also based on this, but I have so there was no question pertaining to Pearson's in last year's question, so that's why I have explained the process how to approach such questions here in detail. But there is a question on Spearman's rank correlation coefficient, that's why I have not gone into detail of to how to implement this formula. Okay, so moving on, we will start with the questions. So there are other concepts also, such as state transition diagram, how the transition probability is calculated. So I thought best way to cover it is using examples. So there are some questions which are part of last year's assignment, which cover very nicely about how to calculate this transition probability. Okay, so that's that one topic we will cover as we go. So if there are any doubts, if things are not clear, or if I'm sounding very confusing, please raise your hands and let me know. Okay, so we'll begin with the questions. Which of the following is not true about correlation coefficient? Yeah, so it is not true. So yeah, it is not true. That means the thing we have to find out the point which is false about correlation coefficient. So option 1, I am getting correct answer by everybody. So option 1, high correlation implies causation. So first rule of statistics, or first rule which is generally covered in correlation is say it loudly, that correlation doesn't mean causation. Causation and correlation are not. So yeah, there is a nice doubt in the chat box that what is causation. So causation is a hypothesis or a statement which establishes that variable 1 is responsible or causing changes to variable 2. Yeah? So simple example would be, if you have viral infection, your temperature rises. So there is a cause for rising temperature or fever, that's a infection which your body is trying to fight, which results into increment of your body temperature, which is fever, right? So infection causes fever is a statement. So where infection is responsible for increasing the body temperature of individual, right? But here in our context, like let's say other example, a person who is coming to class every week. So are you say that only coming to class is enough to score 100% in final exam? If a person is attending the class every week, if a student has 100% attendance, then that student will score 100% in final exam also. Can we say that? There is a correlation that if a student is coming to attend all the lectures, then they will be well versed with the terminologies. It will be easier for them to do the homework. They would know the word, they would know the syllabus, they would know the important points pointed out by the teacher, and so on. So that is going to help them score more, but it's not the cause of score, larger cause of high score, right? So that is the causation. So it's a cardinal rule that correlation is not causation. Yeah. So Ria, I hope I am clear and I have not confused you. Okay, great. So moving on, we'll read all the statements and we'll try to discuss how they are true or how they are false. Okay. The sign indicates the direction of association. Yes, this is true. We discussed this, that the positive sign means the increment in one variable also results in increment in other variable. Then r varies between -1 to +1. Yes, it absolute value lies between 0 to 1, and plus minus is the direction. Yeah, so either it could be positive correlation or negative correlation. Depending on that, the sign will get assigned to the value of r. Then it's a measure of strength of linear association between two numerical variables. So yes, linear, because our Spearman's and Pearson's correlation, both R and rho, they both consider or they both give proper calculations only for linear correlation. That's why this word is important here. Okay, so this also is true, that the value which is lying between -1 to 1, that tells us about the strength, that how these two variables are closely related to each other. Now, what is ISAT? So this is not really conceptual question. This is more for, if you have watched the video, then you would know kind of question. No? So ISAT is a interactive visualization tool, which was shown in one of the lectures, that it is used to show the transitions between, or the shifts between, the variable values, right? So so if this is the variable value at time t1 and this is the variable value at time t2. So another example would be, easier to understand example would be, this would be midterm exam, and this would be final exam, right? So this is performance of student at time t1 and performance of student at time t2. So how each student has scored, in this exam versus how they have scored in the final exam. So you will see something like this, no? So that's ISAT, and it is interactive visual representation to highlight how the data values are transitioning. So going to next question. For correlation between variables, which of the following visualizations would suit? So this we have discussed last week also in very detail about everything. So if to recall, this is the scatter plot where there is absolutely no correlation between two variables, and this is the scatter plot where variables are related, right? So correct answer is scatter plot. That's why visualization or descriptive analytics comes first. It will give you idea about how these variables, whether there exists any correlation or a correlation coefficient, whether there is any correlationship between the dependent and independent variables. So this knowledge we can gain by simply plotting these variables in a simple scatter plot. So that's why in this diagram, descriptive is always first, and we need to understand what the data says. Only then we can do a proper diagnostic analytics. Yeah? Only then we can form our hypothesis that which variables are related, and where to invest our time on to investigation of relationship between the variables, like which variables to consider. Hmm? So here, class teacher of class 8 in school wants to find the correlation between the marks scored in maths and physics in midterm exams. The marks in respective subjects are given in the following table. Now find the Spearman rank correlation coefficient up to 1 decimal place. Okay, so we have to calculate it up to only 1 decimal place. So Spearman's rank correlation coefficient, the first step we will do is we will assign the rank to this data points which we have. So we have student ID, we have maths marks, and we have physics marks, right? So our n is 9. So let's, I'm going to do this. Okay, so let's let's assign the rank to these data points. Okay, so we will arrange it in ascending order. The lowest score will get rank 1. So let's assign the score to maths score. So this will be rank 1, 2, 3, then 4, right, 5, 6, 7, 8 and 9. Okay, now let's assign ranks to the physics score. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So now let us have what is the difference in their rank difference D, and here we will put D square. So 7 minus 5, 2. I am not considering sign here. 5 minus 7 is minus 2, but since ultimately we have to do D square, so that's why I am not considering whether the difference is positive or negative. I am simply putting what is the difference in their ranks. 1, 0, 1, 1, 1, 0, 0. Right? So now let's come to D square. 4, 4, 1, 0, 1, 1, 1, 0, 0. D square and D. So now, what was the formula for rho? This is rho. So rho formula is 1 minus 6 into summation of D square divided by n into n square minus 1, right? So now we have D square value. Now let's do summation of D square. What is summation of D square? 4 plus 4 plus 1, D square is 12. Yeah, 8, 9, 10, 11, 12. Yeah, 12. N is 9. So putting these values in formula, 1 minus 6 into 12 divided by 9 multiplied by 9 9s are 81 minus 1, which is 80. Yeah. Which could be 2, 3, 4. Yeah. So this is 8 by 80, which would be, just putting it in. This is 2 into 4, 8, 8 by 80. Yes, n is sample size, right? And because sample size is total number of samples, or the total number of data points is n. So total number of samples we had were 9. That's why we took n is equal to 9. So I have mentioned it here. N is equal to 9. Yeah. So 8 by 80. So which is 1 minus 8 by 80, which is 1 by 10, 0.1. 1 minus 0.1 is 0.9. We have to do it only till up to 1 decimal point. So our final answer is this, which is option number 3. So yes, correct answer, Ria. So Ria, you were able to understand and follow this process. So I hope there are no doubts. We just have to calculate the rank, then the difference in ranks. Let me do this 7 better. It is looking like 1. Okay, and then calculate the d square, summation of this d square over here, and put these values into the formula. Okay, so I'll move on, or give you some time to assimilate this. Okay, so if similar question comes, you should be able to tackle this. Okay, okay, I'm getting okay, answers. People are getting answers, so I'm taking liberty of moving on to next question. So this, probably I think this is the one question which comes in every week, and by now I think everybody would know that which questions are answered by which type of analytics, such kind of match the columns or match the following type of questions. So this I will not answer. You only tell me what is the correct answer. So let's not check the options, let's go by the questions. That descriptive analytics, what will be 1, 2, 3, 4, what will be the correct match to this, what will happen, how to make something happen, why did something happen, or what happened. It is what has already happened will be part of descriptive analytics, which is describing the data. Then diagnostic analytics, we just now saw on a first slide of today's session, that diagnosing why something has happened, very correct. So I'm getting nice correct answers in the chat box. Then predictive analytics, we are predicting what will happen in near future. Then prescriptive analytics, what to do to make that thing happen, how to make or how to optimize our learning environment. Yeah, so the correct combination is, as all of you have pointed out, the correct combination is option 1. 4 2, 4 2, yeah, right. I hope I have not made any mistake in hurry. 2 3 3 1, yeah, it is correct. So coming to next question, the strength of association between an independent variable and dependent variable is measured by. So when the word association comes, it is always correlation coefficient. What is relationship between them? Association is nothing but how they are related. So that gives us the correct answer, correlation coefficient. Yeah, so all of you are correct in the chat box, correlation coefficient. Okay, so moving on to next question. Yeah, next question is about value of r and how we are interpreting this correlation coefficient value. Okay, so r value given to us is minus 0.5. Okay, so we are breaking it down in the in two parts. So one thing is this minus sign. So minus sign, what do you think minus sign will tell us about the slope of that straight line? Because r deals with linear coefficient, so there is bound to be one straight line whose slope will be upward or downward. So if this is minus sign, that means the slope is downward. Absolutely correct, Ria. So that means the first option is out of question, because first option says slope is upward. So now we have to determine the correct answer between option 2, 3 and 4. So what option 2 says? The slope is downward, which is correct, and half the points of the scatter plot sit on the straight line. That's, we can't say that for sure. Just because here it is 0.5 mentioned, it doesn't mean half the points are sitting on that straight line and half the points are not part of that straight line. It is not so. This value will tell us about the strength of the relationship and not how the values are distributed. Okay, so that means this is also incorrect. Option 3 says slope is downward and all the points sit perfectly on the straight line. No, that is not correct, because if all the points sit perfectly on the straight line, that means there is a perfect correlation. The strength of this correlation is too high, so the value of R should be close to 1, right? So this is wrong. Then option 4 says the slope is downward and there is moderately good fit between the straight line and the points on the scatter plot. So yes, this is correct. There is not, they are not perfectly sitting on that straight line. They are not scattered all over the place in that scatter plot, but they are moderately good fit because of this value of 0.5. So this brings us to correct answer, option number 4. Okay, moving on to next question. Use the following data for next 3 questions. Okay, so these questions are about how to calculate the transition probability between these actions, the transition between the action. Okay, so this I had said that we will cover it with the example. So here comes the example. So now you need to pay attention and we will revise some basic probability concept. Okay, so how we calculate the transition probability is, or any probability. So calculation of probability remains the same irrespective of the domain. So what is the standard formula or definition of probability? Number of possibilities goes into denominator and the number of possibilities which are in our favor, that comes in numerator. So similarly we will calculate this transition probability. So state transition diagram is nothing but where node is your action. So yeah, node is the action. So here this is the sequence of action. This is the first action, this is second, this is third, fourth, fifth, sixth, seventh, and so on, right? So this is the sequence of actions. This is the interaction pattern which is recorded for our system, for our tutoring system, right? So now we have how many distinct actions you can spot in this sequence. First is read, then there is video, then there is quiz. So there are 3 actions, right? So first transition is between read to video, then there is video to quiz, then there is quiz to read, then read to read, that's a self loop. From read it is coming to read, then read quiz, so there is another arrow which goes from read to quiz, from quiz to video, video, so there is self loop here for this node. So every action becomes a node and their transition from one action to other action is represented by directed arrow. Yeah, so this is the state transition diagram. So now there was video to video, we were here, video to video, then video to quiz, this link is already there, then quiz to video, that link is already there, then video to read, so it becomes new link is added, video to read, then read, then read to quiz is already there. So so there are, these are all different possibilities of transition, right? So this is there is no self loop between quiz and quiz, so there is no, so this quiz doesn't have this self loop because there is no transition from quiz to quiz itself. Yeah, so this becomes the state transition diagram for this particular action sequence. But now we need to assign value to each each of the edge which is here. So how we can do this is we have to calculate the probability out of the total transitions in this sequence. What is the probability that action or the user will go from read to video? Okay, so how we will calculate the total number of instances is total number of transitions which are happening from this action read. Okay, so simple formula, so we are considering read to any action. Read to X is read to any action. So how we can count the transitions of read to X or read to any action is we will try to spot how many times read is occurring here. 1, 2, 3. Here the transition is read to read, which is valid transition. Here it is read to quiz. So 1, 2, 3, 4, 5, 6, 7. So read to any action has happened 7 times. Similarly, we'll calculate this, we will count or we will get this count for every action. Okay, so for video to any action, how many times it has happened? So we just have to count video to any action. 1, 2, 3, 4, 5 and 6. 6. Okay, so now I want one volunteer to do the same thing for quiz to any action. Can you tell me what is the number of transitions from quiz action to any action? I'll just remove these underlines and I'll wait for few answers in the chat box. So I'm getting number as 5. Okay, so let's look at this carefully. First transition between quiz to read, okay, 1. Then second transition, quiz to video. Then third, quiz to video. Then fourth, quiz to read. Okay, all of you have counted how many times the action quiz has come in this sequence. But can you tell me, should we consider this last action quiz? Is it transitioning to any other action? Or it is just stopping there? So, did you get my point? We will not consider this quiz, but we will only count the number of transitions. Okay, so if we are considering transitions, then quiz to any, these number of transitions are 1, 2, 3 and 4. Okay, so now we will go to this question. I'm not able to do it. Okay, so read and read quiz. So we have to calculate this transition probability for these action sequences. Okay, right. So R to R. So we know that read to anything is 7. So that means the denominator is going to be 7 for both read to read and read to quiz. So now we have to count how many time read to read transition has occurred and how many time read to quiz has occurred, right? So let's go back and see read to read. So I'm using green pen. Okay, blue, I don't know what is it, I'm not able to select. Okay. So read to read. Okay, read, this is 1, read, then read 2, okay, so 2, and read to quiz. So read quiz, read quiz. Okay, I'll use this another color. Read quiz, read quiz. Okay, half year, read quiz, and read quiz. So 3 times it has transitioned. Yeah. So 2 by 3 and 2 by 7 and 3 by 7. So if we, let me grab my phone to go to the final decimal value. Yeah. So 3 by 7 is 0.43 and 2 by 7 is even lesser than that, 0.285. Okay, so now read quiz we have. Now we have to calculate quiz to read. Yeah? So quiz to read, and let's combine it with quiz to video. So quiz ka total number of transition was 4 we found. So here denominator will be 4. So now let's count how many time quiz to read transition has happened. Okay, yellow. Quiz to read 1, quiz to read, quiz to read 2, 2 times it has happened. Now quiz to video, quiz to video once, quiz video 2, quiz read, no quiz video. So it has also happened twice, which is 0.5, 0.5. Okay, so now video to quiz, right? That's the only remaining. We have read to quiz, quiz to read to quiz, and quiz to read also we have read quiz, we have quiz read, quiz video, quiz read, and quiz video we have. So now this is the only remaining. So video to quiz, total number of transitions video to X are 6, and now let us count how many time video to quiz, video to quiz, video quiz 1, video quiz 2, video quiz, no, just twice, right? So it is 2 by 6, which is 1 by 3, which is 0.33. So now can you tell me which has the highest state transition value? Which combination has highest transition value? This 0.5 and 0.5, which is quiz to read and quiz to video, which is brings us to option number 4. Do you need some time to assimilate this, or everybody agrees that 0.5 are the highest state transition values and option 4 is the correct answer? Yeah, everybody got this? Okay, so we shall move on to next question. So now, what is the state transition diagram up to 2 decimal for read R to R? Yeah. So we know that R to X is 7, the count is 7, right? Yeah, R to X is 7. So now we need to count read to read. Okay. So read to read is here once, read 1, read count is 2, yeah, read count is 2. So here we have calculated that, but I'll do it again. Number is 2, so read to read transition probability is, oh my bad, 2 by 7, which is 0.285, we have already calculated, which is between 0.28 to 0.29. That's the correct answer. Okay, from this, how we will calculate next action of students. So we can't be 100% sure about what is next action of students, but whichever transition has the highest probability value. So like here, in this example, we had the highest probability value of 0.5, right? So if currently the student in our system is solving a quiz, then there are equal chances that he will go to reading, or he can go to watching video, right? 0.5. So we are predicting that student, there is a fair chance that student can go to reading content or student can go to watching the video. So this is how we'll have prediction or probability value associated with next. So suppose there are few more actions in this sequence, like making notes or going to forum. So their probability will be far less compared to these two. So we can say that there is a chance that they can either go to the reading content or video watching, but there is very low chance that they would go to the forum or they would go to making notes. With students, okay, this is the choose the most relevant option that can't be inferred from transition state diagram of a student, given that the actions performed are read, watch video, seek, tech, quiz, review page. Did the student go to certain web page or not? Did student access the quiz just after watching the video? And did student watch the complete video? And did student watch the video or not? Okay, so this is the sequence of action. This is a simple question. You have to consider the sequence of action which you have shared in this question. So this tells us that there was a reading action followed by watching video, then that video was seeked, that the quiz was taken, then review page was visited. Yeah, so now this is the sequence of action. You have only this information. There is no transition probability associated with any of these, because all the transitions are distinct. Every action is happening only once. So transition probability of going from read to video watch is 1, because it is happening only once. Its count is also 1. Yeah, so don't get confused here. So if there is no state transition diagram given to you, only this sequence is given to you, then you can simply say that student go to certain web page or not is something which probably you will not be able to infer. But a student access the quiz just after watching the video, yes, because he was in video watch, he seeked that video, and after that he went on to take the quiz. So yes, that is something you can infer. Then did student watch complete video or not? That is something you can also infer, because this video was seeked. Seek matlab, there's progress bar which you drag and bring that progress of the video to fullest without watching the complete video. So this video was watched completely or not, you can infer that because the action seek is there. So that means the video was not fully watched. So you have to infer such things from these sequence of actions. I'm not sure if there is a state transition diagram given to you, but based on this sequence, these are the things which you can infer. So I have not shared the actual answer with you, but I have given you hint that how to infer this sequence action and how to decipher the options. Okay, so you have to read the option carefully and match it to the actions which are given to you. You will be able to solve it. Okay. Question 9 we are done. There is last question remaining, video to video transition. So video to X is video to any. So the count of video to any we had found was 6, and now video to video. So we have to count video to video. So let's use yellow color. Video to video, there is this once, video transition, video transition twice. Any video to video transition I am missing? No. So 2 and 2 by 6, right? So this was 2. So video to video transition probability is 2 by 6, 1 by 3, 0.33. Okay. Hmm? That was the correct answer. So, any concept you want me to redo or do it again? This is very simple calculations, nothing complicated. Just pay attention to counting, how many times you are counting, and you will be able to do it. And only thing which you need to keep in mind is you have to calculate these are number of transitions, not number of times read has occurred, but how many number of times read action has transitioned to some other action. Okay, let me write it here also. How many times read has transitioned to other actions is read to any. So transition from read to any. Is theory fully needed? No, theory is not needed. You just need to know how to implement it. So the thing which we discussed now is not part of theory, but it is part of practical implementation of these answers. So when you will generate some large state transition diagrams, you should be able to infer those diagrams. If there are some numbers associated with every edge or every node, then you should know what that number means. So the whole point of making you calculate this state transition diagram is so that you should be able to infer the state transition diagrams. So that you know where the what is meant by transition probability and how that number has come there. So you don't need to actually mug up all the theory behind this, or you don't need to understand how the nodes and edges mean, so that's very easy. Every action is a edge. Every action is a node, and the transition is edge. So we here now we can assign value to every edge in this diagram, right? So what is the read probability value was? Read probability value was 0.285. So here 0.285 number comes. So if there is number written along with this edge, so you should know how to infer that number, what to how to what to understand from that number. Yeah. So read to quiz has 0.43, right? And quiz to read and quiz to video has 0.5. So here it will be 0.5, here it will be 0.5. Video to quiz is 0.33. Video to video we have calculated, right? Video to video was 0.33. So similarly we can calculate remaining also, and we can finish this state transition diagram also. So if the question comes that this is the sequence and you have to draw a state transition diagram based on that and assign value, then also you can do it. Why Spearman correlation is needed instead of Pearson's? So I told you that both are the valid methods to calculate correlation coefficient, but if there are some outliers in the sample, outliers are values could be either too large or too small. Yeah. So this too large and too small values, because we are in Pearson's correlation coefficient formula, we are considering the difference between each data point and the mean of that variable. So if that difference, so here, so this is the, so yeah, this is the data point x1, mean of x. Yeah. This is data point from variable 2, mean of y. Yeah. So this calculation will be impacted if there are outliers in the sample. But if we are assigning ranks, then even if there are outliers, even if a particular value is too large, then that particular data point will get highest rank. So we are considering difference in ranks, yeah, not the difference in data points or not their square or their product or anything. So rank is relative, so that relative difference could be too large or too small, that will not impact the ranks. So that's why I say that Spearman's rank correlation is little robust measure of correlation. Yeah, it is not easily impacted by the outliers, whereas Pearson's correlation coefficient can easily be impacted by outliers, whether outliers are on the larger or the higher value side or they are on the lower value side. Yeah, that's why we say that Spearman's rank correlation gives us little robust measure instead of Pearson's correlation. Any more doubts? Yeah, please, you can unmute and ask Riya, or you can type, whatever suits you.
Ma'am, can you please explain the part where SAD has told that a rank variable is assigned if two identical values is there in Spearman correlation,
Okay.
then rank is divided. Can you please explain that part?
Okay. Yeah. So let us consider. So what happens? What Sir meant by that is, if the matching data values are there. Say let's take that same example, no, maths and physics. So maths 40, 40, 38 and 44. And here there are say 38, 36, 40 and 38. So this is our sample. So now we will assign the ranks. So lowest will get rank 1. So now either rank 2, 3 and rank 4. This can be the way, but then that's not correct because 40 is happening twice. So each 40, the rank difference will be messed up, right? So that's why we cannot do this. We cannot assign, or we cannot rank 2 and then skip rank 3, because we are considering difference, right? So that's why we can't do this, assign each rank twice. Even this is not correct. Assigning each rank twice and then moving on, that is also not correct, because we are considering difference. So in that case, what we do is, there is rank 2 and rank 3, because there are 4 data samples, right? So rank should be from 1 to 4. So there is fight between rank 2 and 3, which data point gets rank 2 and which data points get rank 3. So what we will do is, we will find the average of these. So average of rank 2 and 3 is 2.5. So this data point will get rank 2.5. This data point will get rank 2.5. Yeah, so that the difference is not impacted. Difference between ranks is not impacted, because rank of these data points will be different, right? That's why we cannot do this, assign same rank to 2 points and then skip next rank. That is not the correct way. That will not give us the robust or very accurate measure of our correlation coefficient, no? So that's why we average out these ranks in question here. So again, now let's come to physics marks. Now here, lowest will get rank 1, 36. Now this is rank 2, this is rank 2, 2 or 3, whatever, and this has to be rank 4. Yeah, so if we do this, this is incorrect. Yeah, this is not correct, because we will be calculating d square or difference in the ranks. So if the same rank 4 and 2, the difference is 2 4, and but if here also it was 2, then 2 and 2 it would be 0, which would have not given us the correct measure or the correct values for calculation. So that's why again there is tie between rank 2 and 3. So again this becomes 2.5 and 2.5. Why? Because there was a tie between rank 2 and 3, so we averaged out. So if there is a tie between 3 data points, 2 3 and 4, then what we will do is 2 plus 3 plus 4 divided by 3, which is 9 divided by 3, which would be 3. But now here there is tie between just 2 data points, so that's why we will take out the average of the rank in question. So again here it is 2.5 and 2.5. So here they get the same rank, so the difference is 0, and we will calculate the d square value based on this. Okay.
Ma'am, for this example, the rank 4 will same.
I did not understand. Rank 4 will be same as it.
Actually, ma'am, you have told that 2 and 3 has 2 and we will take the 2.5 for 2 and 3 rank.
Because it's the same value, no?
Yes, ma'am. Then
38 and
where is the
38.
3? Can we replace 4 with 3?
No.
Okay.
Because the formula has d and n both, right? That was the whole point of coming up with this average. No? So we have to maintain this n. So ranks will be between 1 to n. 1 to n value, we have to maintain that. How many number of data samples we have to kind of maintain our n value up to that. So that will get compromised only when our top rank is rank in question, like rank 3 and 4, there is tie between rank 3 and 4. Only then we can do that, but otherwise it will be impacted, because if you remember the formula says 1 minus 6 into d square divided by n into n square minus 1, right? So we have to consider n also, and we have to consider d also. So the d difference in ranks, so that is directly related with n, no? So there's very strong correlation between d and n, so we can't mess up these values of d and n. 1 2 2 3, so the difference should not be, so whatever you do same thing for both the values. You do same things for both the variables.
Okay, ma'am. Thank you.
You can do that also and see if the value, the final answer is different or not. But keep in mind, whatever you're doing, do follow the same thing for both the variables. Like this is our variable x and this is our variable y. So whatever way of assigning ranks you are following, follow same for both. Because n is same for both. So if you are using 2.5 for this sample and if you are using 3 and skipping 4, then you will get incorrect value for coefficient for correlation coefficient. So whatever you are doing, follow the same thing, do it, see it, if what is the answer with 1.5 and 2.5, what is the answer with 2 and skipping the 4 altogether. So try doing it, but the standard practice is to do this 2.5, so that the difference is impacted minimally. But I think for smaller samples it will not impact much, so whatever you want you can do it. Okay, let me write that this is about Spearman's rank correlation coefficient. Okay. Any more questions? So if there are no questions, then shall we close this week's session? Okay, so see you all next week. Do we have to do LXTs? So LXTs are not graded, so they are to increase your understanding. So it is advised that you do LXTs, but they will not be graded. Okay, so you can try LXT MCQs and don't worry about the grades as they are not graded, so it will not impact your final score. Okay. Okay, so we will close this session for today here. We'll meet next week and we'll mark halfway there. We will be halfway there next week, so we'll half the battle won in next week. Yeah. So see you all next week. Thank you so much for attending this session. So I'm closing this session for all.